I'm able to. Great. So welcome everyone again to this month's EVs and Grid Integration Working Group call. A few announcements before we hand it over to our speakers. The first announcement is actually not included in the agenda, but Charin is having a webinar next Tuesday, September 16th, on the state of the North American market for SAE J3400, so the next port. That will be at 12 p.m. Eastern time. I'll put the registration link in the chat for you all. But definitely encourage attending that to get that market update on the next connector. The next announcement is that the Alliance for Transportation Electrification released a white paper on managed charging. I'll also put a link for that in the chat. We know that managed charging has come up a lot as a topic of interest with this group, and we'll hear a little bit about it today as well, but wanted to get a sense of whether hearing from the lead authors on this report and this topic would be of interest. So feel free to share your thoughts in the chat, and we can arrange for a call in the next few months with some of those lead authors to learn a little bit more about the report. Next, we have NASEO's annual meeting coming up at the end of October in Nashville. There will be a few transportation sessions on the agenda, but we're still finalizing all of the sessions and details. But definitely let us know if you have any questions about the annual meeting. We're happy to help out there. And then lastly, which we've gone over this last time as well, but NASEO ASHO and the Joint Office are hosting the Western EV Regional Meeting in November in Salt Lake City with the Western Intermountain states. Registration is now open for states, and I believe Jesse just sent over the hotel block registration link. We have a limited number of spots open for private sector folks as well, so we'll be able to engage with private sector folks at that meeting as well. But let us know if you have any questions about any of those announcements, and I will hand it over to Stacy to get us started.
Thanks, Eleni. Thanks for the invitation. Hi, everybody. Stacy Noblet with ICF. I see a couple very familiar names, but look forward to getting to know the rest of the group. I am with ICF. I'm a vice president here. If you're not familiar with ICF, we support a number of different markets, federal, state, local, and commercial. Maybe best known by this group as support for many years to the Clean Cities Network, the Alternative Fuels Data Center, most recently some of the Joint Office technical assistance. I currently support utilities in a lot of program design and implementation of electric vehicle programs of all shapes and sizes. And that's really the backdrop of why Jackie and I are joining you today. So I'll do a little stage setting on kind of this topic that we'll delve into. I'll hand it to Jackie from the Mobility House to dig into some of the technical aspects of their work. We'll come back together for kind of a bit of a conversation between the two of us, and then we would love to have questions from you all. Feel free, of course, to ask at any time. I think this is probably a pretty casual group, or use the chat. So the focus of our kind of conversation today is flexible interconnection. And really the context for this and why Jackie and I are together, working together on this topic is, I mentioned our work with utilities and program design and implementation. Of course, as more focus moves from light duty into medium and heavy duty, impacts on the grid and how to better support those customers. This particular topic of EVs and EV and grid integration is more prominent, more important. So ICF supports fleet advisory services, where on behalf of the utility, we're working directly with fleets to help assess the fleet for electrification opportunities and plan out infrastructure needs, manage charging opportunities, and so on. We also work with utilities to design programs to help support maybe medium and heavy duty vehicle electrification, including in New Jersey. And then, of course, you have utilities in New York and other states that are looking to kind of proactively plan for fleet impacts on the grid. So all that, kind of shines a light on this idea of, the need to have flexible interconnection, the need to kind of understand what really interconnection means. So a couple months ago in May, I published an article in Forbes. I'll drop drop the link in the chat. The title is Bridging the Fleet Electrification Interconnection Gap. And the idea is to kind of introduce the topic of interconnection, talk about why it's a challenge. And to help round out that article, I was able to work with Jackie and her team at the Mobility House, also with First Student, to kind of get an idea of what they're working on, some of the challenges that they're facing and trying to overcome. So maybe to set the stage, when we say interconnection, it's really the steps required to connect EV charging infrastructure to the local power grid. And, that could involve everything from grid studies to transformer upgrades, of course, permitting, utility approvals. It can be a long and winding process. And so, the typical timeline for site prep is relatively short, but when you add grid upgrades, that could mean years of waiting if a fleet wants to electrify, depending on, of course, the region and kind of in the local situation. Where flexible interconnection is ultimately, we want to frame it as an avenue for customers to collaborate with their utility to decide how much power they really need. And rather than simply assuming, it's going to be worst case scenario or highest power needs possible. So the article delves into that. Jackie will go into kind of really set the stage for that and provide some additional context on like real world applications there. The article I mentioned, it calls out First Student. You might recognize the name for school bus operation. They're actually working with over 100 different utilities across North America. You've got, more sophisticated investor owned utilities and more rural co-ops. And despite that diversity, they've actually never had never had a project abandoned because of interconnection challenges. So I say that because, we hear a lot in the industry about these timelines are so much of a challenge and so daunting. At the end of the day, there are multiple solutions or workarounds or opportunities, again, to collaborate with the utility to get to the end result. So we want to talk a little bit about what a frictionless interconnection process might look like in the future, and try to educate you all on what the opportunities to help out in that respect. So with that, I'd like to hand it over to Jackie to introduce herself, the Mobility House, to provide even more detail on this topic, and then we'll come back together for a conversation.
Thanks, Stacy. I'm Jackie Piero. I'm the U.S. Head of Policy for the Mobility House. And I am here, as Stacy said, to talk to you about our experience in the United States with flexible connections, with connecting sites in constrained grid conditions in general. Okay, so flexible connections for faster fleet electrification is the goal and what we're going to talk about. First, who is the Mobility House and why am I qualified to talk to you about this? We are a 15-year-old company. We've been focusing on fleet electrification and charge management systems to control how fleets charge their electric vehicles. So that's just making sure that the cars or the trucks are all charged on time when they should be and to the level they should be, doing it at least cost, taking into account electric rates, demand charges, and then more sophisticated applications where we may be optimizing for an on-site battery, on-site solar, working within a microgrid, anything that's needed to get these things online and working. We've been working in Europe for much longer than in the United States, which is why we have these numbers on the screen. Those are not all in the United States. In the US, we've been focusing for our go-to-market segments on transit and school buses. So these are actually some of the largest transportation cases that are happening in the United States right now. We do that against the backdrop of the fact that load growth is increasing in the United States for the first time in several decades. Energy efficiency, better appliances have made it so that really for more like 30 years than 20, we just have not seen any real load growth. And what that means is that there are few, if any, employees working at utilities today who have seen load growth during their careers. And so we're not super prepared for this moment. It's not that we're not going to meet it. It's just that this is something new from our perspective. And As the load growth increases, so does the investment. At this point, we have switched over so that more commercial activity is related to grid investment than is related to oil and gas investment in the United States. So we need to get this right. You can see that the regions where this load growth is happening are pretty spread out. It's not in one place. A lot of this is data centers. It's also new manufacturing. But even though those aren't transportation electrification, those just take up that many more resources so that when we show up with a transit site that we want to electrify, there just isn't as much grid left over as there would be or would have been 10 years ago if we wanted to try it. We also are doing this against the backdrop of supply chain bottlenecks. This is something that first became really apparent in 2020, not really because of COVID, but it was exacerbated by COVID. We just don't have enough transformers, enough substations being built for the need. And we can see the backlog is increasing, but the rate at which they're being built is not currently increasing. There have been various efforts to try to increase the amount of components being manufactured, but there hasn't been a lot of success. And so utilities are also waiting in line for these components that they will need, as Stacy was saying, if I come and ask for a 10 megawatt connection for my transit fleet that I'm going to connect, we're probably going to need a grid upgrade for that. And for a transformer bank, it might be 2 to 3 years. If it's a substation, it could be 5 to 10 years. And so that is tantamount to canceling the project. And so how do we, the question that we're addressing in this presentation is, how do we work with utilities to make sure that electrification doesn't come to a screeching halt when they need to do a grid upgrade? Because the truth of the matter is, even without this supply chain constraint, there's a basic time frame mismatch between the time it takes to set up a parking lot for charging, could be months to do the work that happens on the customer's site, and the time that it naturally takes for the grid to get ready for that same lot, and that is years. This hadn't been a problem in the past because usually if you had a big new electrical load like that, it was going to be a Walmart. And it was going to take multiple years for the company to build that factory or that huge building. And so the utility had lots of notice to be able to go through their process at their pace. I don't have that anymore. So one of the solutions, one of the many solutions, is a technology called load management, automated load management. This is a lot of text, but really what it means is using software to coordinate the way that a fleet of electric vehicles charge so they don't all charge at the same time. And that way you can cram way more electric vehicle chargers and electric vehicles into a parking lot than the electric grid should be able to serve coming to that lot. And that was the basis for this idea that utilities are more and more thinking about how they can change how they plan their grids and how they build their grids. Because when we first went to utilities to start talking about this technology, we were actually pitching just that the physical connection to the site didn't need to be upgraded. And wouldn't that be great? It would save time, it would save money. And every utility said, yes, that's true. What about our side? What about maybe you don't want to upgrade your service panel on the site, but we actually may have a constraint at our transformer that is going to stop that site from electrifying. And so how can we have electric vehicles charging in a way that responds to a constraint that is somewhere else on the grid? And we're able to do this. We're able to entertain this idea because we've been working with this technology and these concepts for much longer in Europe. In the UK, there has been really over 10 years now that they have been facing these exact problems we're just starting to talk about in the United States. And so there's a lot to learn about regulatory development, about customer rights, about customer journeys, and just about the technology in general, that we don't have to reinvent these wheels. And so things are moving much faster in the United States because of that. So the difference between just load management, as I said, and an actual flexible connection that Stacy was discussing is this idea that a utility may be saying, you're asking for 5 megawatts of capacity to come to your site. At our transformer, that is the conduit to the grid that's going to bring it to the site, we actually can only add 3 more megawatts. Otherwise, we have to do an upgrade. So if we go beyond what your nameplate ask is, if everything was going to charge at once, and you say, maybe we can actually stagger our charging, can you do with 3? Because if you can do it 3, we are in business and you can go ahead and electrify. That's the basic, simplest way to talk about this idea of a flexible connection. It's simply, rather than a traditional connection like this, where the gray line is showing during some times of the day, our substation has plenty of room for energy to come through it, but then there's a peak of usage and it can't add any more new chargers to anything that would be charging there. We have to then assume we can only use a worst case scenario amount of electricity at our site. We can only work with the minimum amount they have. And so we have to stay below what the grid can send, which makes sense. But if you start to trust that a company like mine can reliably control how those chargers are working, you can say, well, actually, if the natural behavior, if people just came, plugged in their chargers, and they just started charging, maybe that naturally would be more electric usage than we can handle on the grid. But we know that the mobility house can reliably say, nope, we're not going to charge that yet. We're going to charge it in an hour. Then we can say, okay, we can plug in more load, more chargers, and we're still working with the worst case scenario for the grid, but we can have more chargers than we should. And this is what you'll hear people call this a static flexible connection. It's just one limit that the customer is signing a contract with the utility that they will never exceed. And this is the difference between a time of use electric rate or a demand charge. Those are price signals that say, yeah, but if you really want to charge, you can. You just have to pay for it. And because of that, usually the utility has to build for the customer to decide they just want to pay for it. The difference here is there's a contract in place that the customer says, no, we are never going to use more than we promised we would use. And then the utility can start trusting it and building their grid around that contract. The thing that utilities are starting to think about more as it gets more useful is this idea of a truly flexible connection, meaning rather than saying we are going to have our site limit be associated only with the least available capacity we ever have on the grid to serve it, we're actually going to have the site limit change based on what the grid can serve at that time. And that is when we actually start to more efficiently use the grid. We are recognizing how much capacity is available on the grid at any given time and saying to the customer, you wanted 5 megawatts, you can only have 2 for most of the day, but later in the day you can have 4, and we're going to give you a schedule. And if you can respect that schedule, again, we are in business. And this allows way more electrification to happen on a circuit on the wider electric grid that normally would require a multi-year upgrade. In terms of what does it take for utilities to trust these systems, there has to be good data, good standard communications. We use the Open Charge Point Protocol, which is an open standard that is really just de facto across the industry at this point, that all charging stations use this to communicate with external entities. And because of that, if the mobility house is controlling a site so that we can cram more EVs onto the grid, and isn't this great? If for some reason the customer decides they don't like us anymore, if we go out of business, they can switch in another company that also speaks this communication protocol and continue operating their site in the manner that they were. I think we would do better, but someone else can come in and take over the site. And this is really important. We've seen with companies that use proprietary systems, if something happens to them, then you have a bunch of very expensive doorstops sitting on your site. You can't charge those EVs anymore. And so having secure, fast, open standards-based systems are really the bedrock of being able to do this in a way that utilities are interested in seeing. We also have hard wiring. This isn't necessarily required by all utilities, but we're finding that they like it, is that we have a little controller that's placed on the site so that if we lose the internet connection, the site can still keep working as it would have. There are definitely vendors that have their web portal talking directly to each charging station. We think that we should use an on-site controller, but there are others that do it that way. It's cheaper, but if your internet goes down, you may lose control of the site. And that reliable control, that constant monitoring is essential to being able to hold this larger capacity than you would normally be able to charge from the grid. I want to talk a little bit about our experience in the United States, the different utilities and states that we've had some experiences with. And I apologize, I'm just noticing that Connecticut should be covered in there, colored in there. So if there's someone from Connecticut, you guys are working on this too. In general, what utilities are looking at is how do we trust these systems? How do we communicate with these systems? How do we measure what these systems are doing? And so, if we just kind of walk around the country a little bit, in Colorado, we are working with a utility who is very interested in using their current infrastructure that they use to communicate with distributed devices on their system to also communicate with EVs. And so we've been working with them to distill their existing communications protocols that they use for solar and batteries on their system so that we just have the few messages that a fleet of EVs would need to send these site constraints. And that, call it a dialect of existing communications protocols, is something that we've seen other utilities very interested in using. It needs to be something that clicks into the way that they already work. In Washington State, we have a utility that's wanting to have public charging sites be able to have these flexible, optimized connections. They also have a microgrid where they want to do the same kind of work for EVs. They're worried about their distribution capacity in the winter when the heating comes on, that they're not going to be able to work with these huge new loads that are coming as the EVs get added to the grid. Actually, we have a site in Canada where there's a utility-owned public charging site, so they need to be able to have billing that reflects how this is working, and they're thinking of associating a flexible connection with a rate because they're actually looking into maybe replacing some somewhat effective but very punitive types of demand charges with a flexible connection-based rate to try to make what they're thinking will actually be a better experience for their large customers that have some peaks that could probably be mitigated if they had the correct technology rather than a really brutal price signal. In Connecticut, we have a utility intermediary that does the signaling and the grid optimization for the utility that we're working with, that the utility is then watching and working with us. And we're doing a transit site. This is critical infrastructure. This stuff has to work. So we need to figure out how do we do a flexible connection where we can make it absolutely reliable that that fleet will get its charge when it needs it while cramming it into the grid. There's no backup transit system, and so it has to work. In New York, we're experimenting with Con Ed on a NYSERDA grant, using a utility retail meter to receive the signals and the requests for us to change our charging level or change the overall level of charging at the site, because they're looking for scalable architectures. How do they use these mass implemented pieces of their infrastructure to facilitate this new solution? In California, we have a few customers in PG&E that have these very simple flat limits on their load, or blocks. You can charge at one time of the day, but not at the other. We're also participating in California's EV energization timeline proceeding, where they're starting to sketch out what the regulatory outlines for flexible connections, making them standard, would look like. And I would encourage you, there's some pretty rich documents that SoCal Edison and PG&E have already submitted about how they are doing flexible connections in a very practical way to try to create the record there. And then in Illinois, I've been a subject matter expert in their regulatory development process for flexible connections. They're working on both the solar side for generation and then also on the EV side. How do we get more of both into the grid? And that is actually probably the most advanced formal regulatory development in the country if you're looking for it. And then we have Maine, who's actually gotten a federal grant for one of the major utilities to do a flexible connection research. And we have utilities around the country, as they're submitting medium and heavy duty make ready requests or rate cases, they're starting to include things about flexible connections in them, and that's what we're seeing in Maryland and New Jersey. So that's, I think, all I have.
Thanks, Jackie. I'll just quickly ask you to address Jesse's question. I think if you back up one slide, she said, when I hear a utility talk about a relay, which component is that here, if it's reflected at all?
It would actually be on the other side of the meter by the grid connection. And so that is when they're still trying to decide if they trust it, if they trust these systems. Can they have something that will just, this site's usage has gone out of control. We just need something that's going to click off. That's generally what that's for. I've heard of dynamic relays that can be set so that the site can actually have a profile that's more than one thing that would be respected. And I know that that's something that has been used in other cases. So I think utilities are looking to that too. Excellent.
Yeah, maybe you can put the map back up. I just some maybe digging a little bit deeper. A lot of what you walked through here are either like kind of utility regulatory, stage setting. Maybe we can talk a little bit about some of the incentives that utilities are putting in place that besides price signals. So one I know our team supports is LMTIP in New York, so the Load Management Technology Incentive Program. And I guess this does relate back to the diagram, but like at what point can incentives be applied to help encourage ALM more broadly, I guess regardless of the flexible interconnection, environment?
Yeah, the LMTIP, I think it's a great first step that the New York utilities are taking because they don't have full regulatory development. And so they put this out saying, we will compensate you for accepting a flexible connection and for complying with the changes that we would ask for. But we also will help with the cost of any of the new devices or control schemes that you would need, any of the hardware and software that customers would need to be able to actually accept a flexible connection, be confident that they can both respect the contract and get their charging done. And so, by doing that, they're able to say, we want you to use open standards. We want you to use the new power control system certification that increases the utilities trust of these systems. And so they are actually starting to make the shape of what these programs really look like, even though they don't have a fully formal regulation yet.
Okay. Yep. Yeah, and I think, we've seen good progress on the residential side. And, Delaney mentioned kind of the managed charging reports, and there's a lot of literature kind of looking back on the progress that's been made in the residential space. But fleet managed charging, commercial context is much more complicated for a lot of reasons. You mentioned, like, there's no backup transit agency. These vehicles have to move, and their mission is the number one priority. Load management might be second, third, fourth down the list, not to mention the layers and the partnerships that are involved. So I guess, what other opportunities are there to, provide technical assistance or financial assistance that, you haven't already covered?
Yeah, I think it's been interesting to see as the California utilities have started just kind of trying this stuff. There are some things that I think are very good they've done, and there are some things that you can see that they'll need to do down the road. And one of them, I think, is maybe an approved vendor list. Just so that even though many fleets will already have a charge management system for the reasons that I laid out at the beginning of the presentation, they just need to be able to make sure their fleets are getting out the door when they should be out, and it's not normal fleet management activity. So they may already know or have a vendor that could help them with this, but if they don't, if they're just starting to electrify, it would definitely be helpful if states or utilities can have some kind of technical requirements or some kind of vetting process to help customers understand who are good faith actors who can actually provide this service. That's one. The other would be if the utility has the capability, this is something that my company does, but I don't think every company does it. The customer needs to have some kind of assurance that they are going to be able to meet their mobility needs if they sign this contract that restricts the level of energy that they can have at any given time. And so you need some kind of modeling or simulation of that fleet to say, these are the number of kilowatt hours we need to get into your batteries every day, and we can do it. We've done the math. Here's how it's going to look. Here's the type of chargers that you're going to want for your lot to do that. Utilities, that could be part of the technical assistance that they could provide, particularly because right now it's kind of luck or marketing. If a customer finds a company that can help them with that site design, the fleet of electrification planning to set them up for success. If the utility has those capabilities, it would provide a far more equitable access to this option than currently exists.
Yeah, that's great points. And yeah, just to make connection back, I mentioned First Student, for everyone's reference. Their solution is focused more on the hardware side of things, so very different from what the Mobility House is doing, but it is, modular to accommodate things like leased property and other, site-specific considerations. So those are the kind of things that do become uncovered when technical assistance, when a conversation is happening, versus just assuming that every site, is can be repeated, or all things are created equal. So the uniqueness of these charging systems, charging setups, really does require a case by case sort of approach, which feels not so scalable when we think about the number of fleets interested in the load, but even more, I think, important that utilities and customers and vendors are all kind of having these conversations and exchanging notes.
Yeah, I think the other thing that is, I can see it changing actually. When I first got into this industry, utilities did not want to talk to a vendor that was working with the customer. They only wanted to talk directly with the customer, which is understandable. Now, as we're starting to have these kinds of opportunities, you're having way more joint calls, joint planning calls with the utility and the vendor and the developer and the customer to agree, get everyone on the same page, but acknowledge that there is going to be another third party that's going to be helping the customer be able to sign this contract, be able to take advantage of this opportunity.
Yeah, that was a really great point. Anything else, Jackie, on like just partnerships? I mean, you all are like hardware agnostic for the most part. I mean, I'm sure you had preferences, but given your experience, but anything else in terms of important partnerships that kind of set the tone for this landscape?
I do think, again, I just have to say it again, the companies that are working with open standards are the ones that you want to work with. And you know, we've seen the consequences of not doing that. And you know, it's very good to see that some of the private charging networks are starting to standardize and be more available. And so that's raises all ships, but it also mitigates the danger if something happens to an individual company. The other thing I think is that we're seeing more and more complicated sites where there is a battery on site or there is solar, or we're seeing it more and more common that, particularly with transits and schools, that they have some kind of a backup generator for if the grid goes down. It might be a battery or it might just be a diesel generator, but that generator is almost certainly not going to be a perfect replacement for the grid. It's going to be smaller. And so you need to be able to have a system where we can say, oh, the grid went down. We don't have 2 megawatts coming into the lot anymore. We have a third of that. And so we need to figure out with that transit agency, how do you want to run your fleet in that situation? And we're going to design a way for you to do it just in case. But those critical infrastructure components are more and more saying we need resilience, we need reliability, and it is related very closely to this.
Yeah, I know. And I know that many of especially the state offices on the call deal with that on a regular basis, the resiliency piece. So
yeah, a good example of that is in Rhode Island. It's RIPTA. They have a load managed connection with them, and they do have a backup generator that is a different size, and it has worked several times in the last couple of years, and so we're pretty excited to see that actually can operate as intended, and so we're seeing more and more sites do that.
excellent. Well, Delaney, I think we're ready to open it to questions. If folks want to come off mute, happy to moderate to the extent that that's necessary, but definitely want to hear from the group, either in chat or in person.
Sounds great. Thanks, Stacy and Jacqueline. I guess I have a question to get us started. Were you all seeing that fleets were stressing the need to have like a backup, like diesel or gas powered bus or whatever it may be? Or were they, really fully set on electrification and wanting to just work with you all to explore other backup solutions that isn't like a backup bus?
It's not so much that the way that fleets usually go at it is they kind of dip their toe in. It may be like, we're going to do 2. We have 30, we're going to start with 2, see how it goes. And then once we've done that for a year or 2, we're going to go back to whatever funding source that we went to, and we're going to do a much bigger chunk of the fleet. It might be the rest of the fleet, or they might just be phasing it as they go. Or, when we had these big federal funding tranches, you would have schools, transits, et cetera, doing, we're going to do 20 now, we have 60, we're going to do 40 later. And this actually has caused some issues with utilities infrastructure programs. They're called make-ready programs. This is where the utility actually has funded and helped design and build all the lines and infrastructure that the customer will need. In California is the best example. They assume that you're only going to do this once in maybe 10 years. And that made sense before you had these huge pots of funding that schools could go back to. and multiple times be expanding their fleet electrification programs. And so then they go back to the utility, and the utility says, well, you already used our program. We can't put you in it again. And so what do you do then? So I think as electrification accelerates, there are multiple pieces of utilities, operations, planning, and their rate cases that are going to evolve. That was a bit of a safari from do they use backup buses? But
No, that was really helpful. And definitely, I didn't think about the whole make ready piece and how a customer may have already used that and kind of need another option to bring additional buses
Yeah,
online.
and I think the good thing is there actually aren't very many medium and heavy duty utility infrastructure programs in the US yet. We're just starting to see them in the few states that were really at the leading edge. And so I think there's a chance for substantive lessons learned on how to design those programs. And actually, the New York utilities are right now kind of asking for an iteration and a revision of how they're doing it. And I think that's just great to not wait until the end of a cycle to fix something that's not working.
Jesse.
Any other hands up? Yeah, so I'll jump in with one of mine too. I know we've been talking a lot about kind of the fleet perspective, and I think that makes sense since my perspective is they have a lot more flexibility of just like, I need the truck charged by the time it has to roll out tomorrow or the bus or whatever it is. I know a lot of our work with this working group has been focused more on public charging and more for passenger vehicles. And I imagine those drivers have much less flexibility. They're trying to get in and out as quick as possible. And so I'm curious, just kind of any general thoughts on what you see as the role for automated load management for those sites, those types of public charging sites. And then specifically, if you're seeing any kind of best practices develop around, you can throttle the power a little if needed, but it's best not to go below, 150 kW or anything like that. I'm just curious.
Yeah. I mean, honestly, I think anybody who's gone to a public charging site has probably experienced that it's already happening somewhat. They just don't really mention it. You're at a 150 and you're getting 75 for some reason. That's because the person next to you is also getting 75. But so how do we make that a little more transparent and a little more clear that that is going to happen or will happen? Part of that is a business model issue for the guys that are running the site. But I think also we're seeing that they're saying maybe we need a battery actually that we can use to optimize our site. And also I think as these sites grow, as the utilization changes, then we're going to get a less like spiky load profile that we can figure out a little more. How do you optimize that site? Also, it looks like my colleague is on in Sam Hill Crystal, and so I think he has something to say. Sam?
Yeah, I love the question, Jesse. I couldn't help myself from chiming in because I've been doing a bunch of these projects. And so we actually have two examples now of utility-owned public charging, where the utility has actually sought this solution for their own chargers, where they have a network, one in Canada, one in the Pacific Northwest. And they have, it's a rural grid in one case, or it's just the other case is just suburban, but they just don't have enough capacity themselves, And so even for their own sites, they're looking for this control. And we're able to sort of plug in as an energy management layer between the grid and the charger and the software that the charger normally has to process payments and have an app. So it's the architecture is actually really nice because we're not displacing, the existing software that is already used to sort of interact with the driver. So it's somewhat, it doesn't affect the user experience, which is like I think a super big key. And then I do have also one example of a developer who's actually like a public charging developer who's actually engaged us because they've realized like we will never have 20 Porsche Taycans pulling up at the same time. those are the only cars that can actually charge at 350 kW. And so there is efficiency to be found when it comes to having a grid connection that's undersized. And in some ways, you could argue that public charging is actually the best use case because like the demand from the customer is maybe slightly more elastic than a fleet. Like you could make that argument. I think often we don't make that argument. We think of it the other way. We think of it like you pull up at a Walmart or you pull up at a fast charging hub on I-95 and you need to get max capacity. But like I don't know. You could make an argument that actually the personal driver could delay a bit more than the transit bus, right? So, I think the industry is sort of coming around to some of that. But it really depends on what charge point operator you're talking about and how they market themselves and what they want their user experience to be. And so, but I think it's like super relevant to public charging. And if you asked me 8 months ago, I probably would have said no, it's not relevant at all. So it's really been interesting.
That
Yeah,
is
I'll
interesting.
I was gonna say,
Go ahead.
maybe dissent a little bit because Sam and I are friends, so I feel comfortable saying I agree that there's opportunity in public charging that we didn't see before. I would caution, we're not there yet in terms of the customer experience to be messing with that on-demand piece right now. So I think that most developers, site hosts, are looking for these types of solutions to avoid demand charges and to smooth out load from a like cost perspective. I would just want to be super careful about thinking through the user experience because we are in this maybe delicate space that you want to make sure early adopters and maybe more I don't know, people who are just like kind of getting over that hump of okay, I'm ready to drive an EV. They're pulling up to a station that's super slow. That experience isn't ideal. But I think that there are some really cool pilots and tests happening. I was recently at the Peak Load Management Alliance EV Symposium, and I'm blanking on the name of the company, but it was in the UK that they were piloting it. But the idea of if the stations, if EV drivers are able to get a blast, when you think of gig drivers, for example, rideshare, for example, if they get a blast that say this station is cheap right now, if you need to charge in the next 4 hours, go there, or those kind of like price signals, those could be really impactful to shift load to certain areas. But right now, one of the best tools we have is utilities publishing capacity maps and having conversations with developers about where to put the stations. And, of course, with the load in mind, but placing those stations and kind of where they integrate with the grid is the starting point for that conversation.
Yeah,
Yeah,
I
and I
think that's
think
a great point. Fair dissent. Just quick, Jackie. I think the utility-owned public networks might be like this middle ground, right? Where they're kind of like, we want to help industry, but it's not their core business model. So I don't think it's a coincidence that we've seen interest from these utilities that are owning their own public charging in this solution because they have maybe a bit more flexibility in the experience that they're on the hook to offer.
Yeah.
I think though that the fast charging companies are a bit like the data centers in that in the perfect situation for this business model, they want 100% nameplate 99.9% of the time. But if it's choice between that, but you have to wait 5 years, and if you figure out some way to manage your load and you can be on in a year or 2 years, they're going to figure out a way to manage their load. So, there's the perfect, and then there's where we are. I wanted to also drive home that there are multiple gradations of this solution and this concept. There are ones that require way less technology on the utility side that can be just sort of, we're putting we know how much space we have on the grid. We're going to work with the worst case. We're putting a flat top on you and you can still get on the grid. All the way up to we have an intelligent platform managing our entire system and we want to talk to you hourly and multiple things in between. So any state that is facing or utility that is facing large loads popping up in places where they've never been before, you have multiple options no matter where you are in that technology development spectrum. I also wanted to note that I've been an SME for an initiative from Grid Lab, Rocky Mountain Institute, and Advanced Energy United, all nonprofits, that they're putting together generic flexible connection policies that both regulators and utilities will be able to use as a starting point if they want to jump in and don't know where to start. And it's everything from what's the RACI need to look like inside the utility to what does the contract need to look like to make sure that the customer is actually doing this in a safe way. If you're interested in that, it's called Charged. It is the Charged Initiative, and I think it's going to have its first output in October.
Any other questions? Feel free to reach out. I think Jackie will say the same. If we can follow up on anything, questions arise later, you're welcome to filter those through Delaney or reach out directly. But I think with that, Delaney, we'll hand it back to you.
Yes, thank you so much. This has been really informative, and I think a lot of great information and insight from you all. So thank you both, Stacy and Jacqueline, for presenting today. We will get this presentation recording uploaded to our YouTube soon, and then I can, providing I have both your permission, share your PowerPoint slides as well. But I want to thank you again and thank everyone for attending. I will note our next call has been rescheduled just to, I think, the week after, or 2 weeks after the normally scheduled. So it'll be Tuesday, October 21st at 2 p.m. If you don't have that calendar invite, let me know and I can pass it along. But with that, I'll let you have a few minutes back in your day, and thank you so much.
Thank you.
Thank you for having us.
Bye.